Welcome back. Today we're going to be looking at factoring, finishing up factoring, all the other types that we haven't done yet. We're going to get started fast because there's like 4 or 5 different types. So let's start with our creed and then we'll get started. Today is a new day. I can read and remember well. I can develop my viewpoint and apply it correctly. I have eyes to see, ears to hear, and a mind to understand. Might not be easy, but it's worth it. All right, let's get started. So, like I said, we're going to be doing other types of factoring. This is just a hodgepodge, a bunch of different random types of factoring that you are going to see, and that is really important to recognize. And it's no new skills. It's not skills, new math skills or new learning that you haven't done. It's just kind of applying them in a different way or a new way. So we'll see that as we get started. So, and we did this in class a little bit where we showed you there's no one right way to do this, right? If you want to divide by whatever's on one side, you can do that, keeping in mind the dividing by 0. If you want to move everything to one side, you can do that. But the key point that we're trying to emphasize is that you have to follow the math rules, not you have to do what I say to do, right? So if you want to move 3x to the 4th to the right side, that's okay. If you want to move 27x squared to the left side, that's okay. As long as you follow the rules of what you do to one side, you have to do to the other. You're going to be safe. But if you're just trying to do what I tell you to do, then 10 problems down the road, you might run into a snag. So let's look at this first 2, I guess. Yeah, it's really just 2. And any problem you see like this, you might notice something about these 2 types of problems. And that's that they have something in common. Like when I see these 2 problems, I see something, these 2 have either a number with a factor in common or an x in common, right? There's a like term in between the 2 of them. So what I'm going to do to start, because I know it's a safe thing to do, is like what I do to one side, I'm allowed to do to the other side, right? So I'm going to subtract 27x squared because I just like to keep the bigger one in front, kind of like that generic form of the polynomial. So we got 3x to the 4 minus 27x squared equals 0. That kind of looks like a normal polynomial. And like I was saying, you might have something in common that you see happening, right? So I see something in common there. I see a 3 in common. So what I'm going to do, and sometimes we call it factoring, but what I've kind of come to express it as so you really can recognize it is it's like a reverse distribution, right? So you remember that distributive property. Well, what we're doing is we're factoring out or reverse distributing whatever's in common. And I definitely see a 3 in common, right? And what else do we see that might be in common? Probably an x squared. So if we reverse distribute that or factor it out, we'd be left with 3x squared parentheses. The 3 comes out and turns into a 1, right? Because 3 divided by 3 is 1. The x to the 4th divided by x squared is x squared minus 9. And that x squared over x squared turns into a 1, right? And now we've got our 0 on the other side still. And then boom, now we can apply that property that we talked about maybe 2 or 3 sets ago, where we talked about a times b equals 0, has 2 unique solutions. A equals 0 or b equals 0 or both. But it's not going to be anything else. There's no other number that can get you 0, right? So from here, we can just set our 2 factors divided by that red line, right, equal to 0. So let's do that. We'll say 3x squared equals 0. And then we'll say x squared minus 9 equals 0. All right? And now from there, it's just solving 2 normal equations that we've been solving for the whole class. So let's get to it and see what happens. Divided by 3. Hopefully you remember that DCMAM thing. Square root it. And we are left with x equals plus or minus the square root of 0. I added the plus or minus because we remembered anytime we introduce the square root, we put a plus or minus. But 0 nonetheless. All right, let's see what happens on the blue side. X squared equals 9. I move the 9 over by adding it to both sides. A square root. And x equals, boom, I introduced the square root. So I am adding a plus or minus 3, right? Because I introduced the square root, I need to introduce a plus or a minus. All right? And there is our solution set. You can write it nice and neat from smallest to greatest. You're good to go. Cool? Okay. So that's factoring something out. So I'd give you a little hint. Maybe on this one, I would move over the 12x. I like to move it over to so it's big one is positive, right? I like to move it over so it's like that normal polynomial that we always see. And then factor out maybe a 4 and factor out maybe an x squared and see what happens. I'll let you do that one and while we move on to grouping. All right, so that's factoring. That's factoring out a term or reversed. Actually, that's worth mentioning, huh? Might call this entire set of things kind of like reverse distribution or distributive property. Reverse distribution, which is really called factoring out. Cool. All right, now we got to do grouping. Same thing, we're going to get it in that normal polynomial form by subtracting over the two terms with the smaller exponent. I always like to do that because then I don't have to mess with the order. I don't have to move stuff around and put the x to the third in the front. We're good to go. All right. Now, anytime you see an x to the third and you see some kind of simple numbers, I want you to think, anytime you see four terms, 1, 2, 3, 4. Look at the next one. 1, 2, 3, 4. And they're usually, not always, but they're usually an x to the third and less, like a cubic function and less. Not always, though. Sometimes you can group a little bit bigger by pulling out by reverse distributing or factoring out a little bit bigger of an exponent. But usually you're going to see it in this form. So when I look at it, I think, okay, I don't know how to do that because I can't use the quadratic formula because it's not a quadratic. I can't do what I just did. There's nothing in common with all four of those things. What else could you try? No, that's really it. Those are the two tools we have to try it. The other one would be that method where you take the last term, but that only works for quadratics too. So we're stuck here and we're thinking, okay, what can I do? Well, maybe I could just turn it into two different problems, right? Boom, boom. I'm introducing some parentheses, and I want to make a note. I'm not introducing those parentheses to make them multiplication. I'm not changing anything, right? What I'm doing is I'm introducing these parentheses, and if you need to write the plus sign so you can see the plus sign in between them, you can do that. So you know we're not just introducing a multiplication out of nowhere. And then what we're going to do is we're going to say, what's in common on either side? Well, we're going to reverse distribute something out of both sides. So in this one, it looks like it's an x squared, right? And you're probably left with x plus 1. You still have that plus sign in the middle. And then what's going to happen every single time that's really cool is if you reverse factor, we're looking to reverse factor something out that gives me a similar term. So I see something in common, then I'm just going to jump to a conclusion and say it's negative 4, right? All right, let's pretend like it's negative 4. Now I don't need that plus sign because it's on the outside. Because plus negative is the same thing as minus, right? And if I pull out a negative 4 from the first little half, looks like I get a x. If I pull out a negative 4 from the second half, looks like, look at that. Look at those two highlighted terms. They're identical, right? Awesome. So since we have two identical terms, we can refactor those out again, just like we did before. A lot of times you can just look at it in the colors and see what's happening. So if I was going to jump in my brain, like a lot of times in class, maybe I'll make this leap right here. I'll go from this equation to x squared minus 4, taking out those blue terms. You can see they're blue there. And then x plus 1. But the reason I'm allowed to do that is because just like I reverse distributed this x squared and reverse distributed this negative 4, I can reverse distribute this common term of x plus 1 out to the very front, right? So now I'm multiplying x plus 1 by whatever's left in blue. And it's kind of like I'm factoring out this giant term instead of just factoring out a small term. And then we set it equal to 0 because it was equal to 0. And then we solve each of those individually just like before. X squared minus 4 equals 0. X squared equals 4. X equals plus or minus the square root of 4. X equals plus or minus 2. And then the other one's a little bit easier to solve. You just get x equals negative 1, right? So there's my my 3 solutions. There's my solution set. And if you want to think about those in terms of an actual quadratic or an actual polynomial, those are your zeros, right? Those are your roots, zeros, x-intercept solutions. Those are your rocks. So we're negative 2, negative 1, and 2. Cool. All right, that's two types, factoring out and then grouping, which is really just factoring out twice. This one's a little more convoluted, but it's really important to try. Let's do one of these harder ones with 2, even though that's going to be the same steps, but it's this radical. It's this radical type equation where we're going to look at something that has a radical and just work the same process over and over to get rid of that radical. And how do you get rid of a radical? Well, you square it, right? That's how you always get rid of radicals. So we're just going to keep squaring these until they go away. And you'll see. So what I'm going to do to start is I'm going to get them on different sides so I can knock them both out with the same square, right? So watch this. I'm going to get these radicals on different sides. Would you get the same answer if you left it? Absolutely. Would it take you like 6 extra steps? Yeah, it would. If you want to do that, come to office hours, I'll do it both ways. And then we can look at it and be like, oh, look, we ended up with the same thing if I just jumped right into it and squared both sides, right? But what I'm doing now is saving us like 2 or 3 steps in the process. All right, so I moved it over. And now how are we going to get rid of these radicals? Well, I'm just going to square them up, right? Squaring gets rid of a radical. But something really interesting is going to happen that we're going to note at the end. And I think there's steps up above that tell you this step 4 is so important because we have to check to make sure it's not extraneous. But we'll talk about that when we get to the end. I don't know how to spell that word. Extraneous. All right. So if we square the left side, that's the easier one, right? The square of a square root is just what's on the inside. So that was nice and neat. And then the other one, we have to do our FOIL, right? So it ends up with 4 plus 4 square root x minus 3. Oh, we're not done. Plus x minus 3. I'll put it in parentheses, but you don't need them because there's no negative to be distributed. So now we're going to combine like terms. Equals, we've got a 4 and a negative 3 turn into 1. We've got this giant ugly term, which can't combine with anything, and we've got an x. Now we're going to get them on the same side. Minus x, right? Minus 1. Ooh, those x's are going to do something real nice for us. That's not too bad. So we're left with 4 equals. That's actually not too bad at all this time. You might get one that's slightly harder than this. I didn't realize. Then we're going to divide by 4. Divide by 4, right? We're going to end up with 1 equals plus or minus. Wait, I added a plus or minus. We didn't add that square root. The square root of x minus 3. How do we get rid of that? We square it, right? 1 squared. And we end up with 1 equals x minus 3, which kind of tells us x equals plus 3 to both sides, 4. I'm hopping back in to check my solution, right? What's 4 plus 5? Probably 9. Minus 4 minus 3 is probably 1. Equals 2. Whoa. That's not nice, huh? Did I mess something up? Oh, I didn't square root it. I'm so silly. I forgot to add the square roots. Or I forgot to do the square roots. So 3 minus 1 equals 2. Check. We checked it out. It worked fine. All right, x equals 4 is our solution then. Boom, boom, boom. There's our solution set. X equals 4 is our solution. We didn't get to look at this extraneous solution, but we did check our work to make sure it was right. That's because our x's did this nice set of canceling right here. But it is worth mentioning. Check out the full notes. Check out the full completed notes so you can see us do that. All right. We're going to do something real similar here with radicals because if you really stop to think about it, well, a square root really is a radical, right? Anytime you see a square root, it's kind of written the same thing as 3x plus 1 to the 1/2. Those are identical. If you didn't know that, now you do. Drill it into your brain. It's so important to recognize a square root as an exponent, exponent that is a fraction. All right, so let's look at this. If we have an exponent that's a fraction, it's not hard to get rid of, but it is important to keep track of the sign. What's going to happen with this sign as we go? All right. So first things first, we're just trying to get x by itself. I'll do 2 of these so we can see it odd and an even instead of like the other ones. 3x to the 3/4. I'm just moving that 6 over, right? Equals 6. Not too crazy. Oh, look at that. Divide by that 3, right? Take care of the easy stuff first. Take care of the stuff that's working your way up reverse PEMDAS. X to the 3/4 equals 2. Not too crazy. All right, now how do we get rid of this 3/4? This is the step that's in step 2, I believe, up here, where it says raise it to the flipped power. Oh, that's a typo. It'll be fixed when we post it. N over n. We're flipping the fraction to raise it to that power, right? And we'll do the first one in long steps so you can see what happens. So if I raise that to the 4/3, then I have to raise this to the 4/3, right? All right, let's see what happens. I'll show you in slow motion. 3/4 raised to the 4/3, right? Well, we know from our properties of the power rule, right? The exponents being exponented, we can multiply those exponents, right? Just like if exponents are multiplied, we can add them. It always kind of chucks a step down. So now we've got x 3/4 times 4/3, which is equal to x 12/12, which is equal to x1, which is equal to x, right? And that's what we're trying to get is x by itself. So we are allowed to do that. And that's equal to, on that left side, 2 to the 4/3, which is equal to what? 2 to the 4th cube rooted. So let's say, okay, well, what is, if we were going to work this backwards and kind of say 2 to the 4th cube rooted, right? Because 2 to the 4th is a little easier for us to solve. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 cube rooted. Is there anything times itself 3 times that gives us 16? We'll just check the easy numbers. 2 gives you 2 times 2 times 2 is 8. No. 3 gives you 3 times 3 is 9, times 3 is 27. Nope, we just split the difference, 2 and 3. So that's our answer, right? And we could rewrite it as the cube root of 16 if we want to. But then we're going to go and check this last. Then we're going to go and check this last thing where we have to add a sign. It says if m is even, we must add a plus or a minus. All right, well, let's go look at our exponent. Say this was m, right? Even or odd? Odd. That means no plus or minus. That's because the odd preserves the sign, right? Think about -1 being cubed. Here, I'll write it up here. Think about -1 being cubed. The odd exponent preserves the sign, doesn't it? Because -1 times -1 times -1 is -1, right? Because you get a positive there, and then it times a negative is back to the same negative. So any odd number is going to preserve the sign, and any even number, likewise, is going to eliminate your preservation of the sign. We're not going to know for sure whether or not that one that got us our square was a negative or positive, because the negative and the positive being squared give us the same dang answer. It's kind of the whole reason why the square root function isn't a function, right? When you look at the square root function, it's always the top half. We're not looking at the top positive and negative of the square root. It's because we need there to only be one y for every x. And sometimes you get both. So that's why we don't need the plus or minus. If we were looking at something like the next one with the 2 right there, let's go ahead and do this fraction. 2/3, I wrote it backwards. 2/3 equals -1/2 plus 3/4. Adding fractions, it's always good to practice. That's the same thing as 2/4, right? Plus 3/4, which is the same thing as 1/4. So now we can do our multiply by the flip. Oh, we need to make a little note, right? The top is even, which means we got to add a plus or minus at the end. Okay, because our negative sign wasn't preserved. So, that equals x, right? Which is equal to 1/4 with the same power raised. Which, remember, we're going to do the inside of the function, let's do 3, and then outside of the function, let's do the cube root, or the square root this time. So 4 times 4 is 16, times 4 is 64. If I'm wrong, send me an email or yell at me. And then do we know the square root of 64? Absolutely. That's a nice one. It's 8, right? And then what did that fourth step or third step tell us to do? Second step, insert a plus or minus sign if we had an even on the top, which we did. So we've got a solution set of -1/8 and +1/8. But wait, we're not done. Not done. Wait, exclamation point, exclamation point, exclamation point. We need to check. We have to check. Like we did last time, we have to check these square root functions and squared functions when we are introducing the squares and the square roots, because we might have introduced an extraneous solution or one that's not actually there. So let's hop back up to the original thing and throw these in and see what happens. Let's try -1/8. -1/8 to the 2/3. Well, we just did that, didn't we? Or did we not? Yeah, we did. No, we need to do it. -8, that gives us 1/64 to the cube root, right? What times what equals 64? I would guess 4. 4 times 4 is 16 times 4 is 64. Yeah, so that's 1/4. And 1/4 minus 3/4 better give us -2/4, which is equal to -1/2. That's a check. We're good to go. Now, if we replace that -1/8 with or that +1/8 with a -1/8, does it change this first square that we did? It does not. It stays positive, and the rest of ours is going to be the same. So those are both solutions. All right, good to go. That's our solution set. All right, 2 more types. I know this is a lot of types. That's what I said. It's going to be a longer video today. So here's one more type. We'll just do one. Yeah, we'll just do one of these. And this is my favorite type, which is called a U sub. And it's when something's in the quadratic form, but it doesn't look quadratic, right? And I'll help you pick the U's so you can practice. But really, at some point, it's real important to recognize what's happening so you can pick the U on your own. So right here, this looks like something we've never seen. But wait, here's the kind of step in your brain to make. Is can you rewrite x to the 4th as something else? Well, what they're trying to get us to make the leap is x squared is the same thing, right? -8, and I'm going to add these parentheses here so we can kind of see what's happening. -9 equals 0. Now hold up. What if I were to say u, just a random u, pick a random letter, u, equals x squared. And then we're going to take that random, let's even say let. let u equals x squared. I'm going to take that random u and plug it in. U squared, I'll do this real nice and neat with the color so we can see, minus 8. There's another x squared, so u, right? Heck, I can even keep those parentheses in there so you can see what we replaced. Minus 9 equals 0. Well, now, is that a nice easy factor? Let's check. Negative 9, positive 1 turns into negative 8. Yes, it is. So we've got x minus 9 and x plus 1 equals 0. Oh, whoa. I said x, but we don't have x, right? What do we have now? We have this blue u, right? Okay, so all we did is rewrite it a little bit. And now what we're going to do is say, well, we know what u is, don't we? U is x squared minus 9 and x squared plus 1 because we just replace it back in. And now we can solve both of those sides, right? So now we've got plus or minus 3, x equals plus or minus 3, right? And x equals plus or minus 1 as our solution set. That's pretty cool. Plus or minus 1, comma, plus or minus 3. All right? Not too crazy? Sometimes, here, I'll help pick a couple u's. Here we go. You might think about u being x squared when you see that fourth to start it. Here you might say, okay, we really want it to be in the form of a quadratic, so we want to keep this 2 and this 1. So what's a u we could make that gets rid of everything but that's not that 2 and that 1? What if it were u equals x to the 1/3? That might help a little bit. Same thing here on the left. Ooh, and this one might be an easy way to see the u. Let's just say u is all that mess right there. All that mess that they have in common. Let's see what happens. I'm not going to solve it here. It is solved on the completed notes, so you can look at it. But I want you to practice it. Really try and dig through that problem because it's not a super obvious one. All right, last but not least is absolute value functions. These are really important because they keep popping up with inequalities and absolute values, and they're really important to see and to work through. So let's just pick one and go. So basically all this is saying is if you see an absolute value, you want to get that absolute value by itself, right? So this one, if we look at it, check. But the absolute value is by itself, right? I'm going to write that, by itself. This one, it's not by itself, right? This 5 is keeping it hostage, and this negative 15 is keeping it from being by itself. So we have to move those before we can get it by itself. All right, so let's do this one because it's a little bit tougher. If we want to get that absolute value by itself, first I would add this 15. Just treat it like the absolute value is a variable, right? So now I'm going to be left with 5 absolute value, all that mess, equals positive 15. Still not by itself. I've got to divide, right? I'm not even touching the absolute value yet. I'm just messing around to try to get it by itself before we do this application of the property. Absolute value of 1 minus 4x equals 3. Now we can apply the property. And you'll see this because we did it kind of in linear equations as well. I think this is really interesting, is that when we worked with linear equations, when we worked with linear inequalities, not equations, linear inequalities, remember when there was an absolute value of x, and let's just say less than or equal to 3. Do you remember what we did? We added the same sign in a smooth sequence or in a parallel sequence or facing the same direction, and we flipped the sign to negative 3, right? Well, we're doing the exact same thing here, just there's no way to flip an equal sign, so we just add an equal sign to the other side and give ourselves our other solution of negative 3, right? So wait, that might not have been clear, but now what I've done is I've created 2 different equations. I've created 1 minus 4x equals 3, which was our original equation. And then I've created the opposite of that, right? I've created the negative of that, which is distancing or creating the positive out of the negative for this absolute value, which is exactly what we did. We just added a negative sign to the outside of the absolute value. So then we've also got 1 minus 4x equals negative 3. It's 2 different problems. I really want to stress that. It's not that we're making it one problem. It's that we're creating 2 problems, one with a positive, one with a negative. If you look up here, that's kind of what they did. They said when you get the absolute value by itself, one has a positive, one has a negative. Cool? Okay, so let's see what happens. If we just solve this in normal style, we'd probably get 1 minus 4x equals 3. We'd probably get negative 4x equals 2. Probably get x equals negative 1/2. And since it's not an inequality with one of those signs, we don't have to think about flipping the sign when we divide by a negative. Then normally we would. All right, so then on the other side of things, we got 1 minus 4x equals, this time, negative 3. Subtract that 1 over, you're probably negative 4x equals negative 4. And then you're probably looking at x equals 1 when you divide those out. That's the blue side, right? Let's see, boop, boop, boop. Blue side, red side. And that's how we work with the absolute values. A little bit easier on that top 2 because you don't have to get it by itself first. but I think those are probably the easiest out of all these sets. All right, so those are five new types of factoring. Let's think about them if we can recall them or retrieve them without any help or looking at the paper. So we talked lastly about absolute value and how we add something to both sides, right? Then we talked about use substitution and making our use something so that the function or the polynomial looks like x squared plus x plus 1, right? Or something like that. So it looks like a normal quadratic equation that we can factor. Then we talked about factoring out or reverse distributing a term so we can get two easy factors, right? If it looks like there's only two terms and they have something in common, you can just reverse distribute or factor out the common thing and see if you can solve. And then we said maybe sometimes you have four things, so you have to do two separate reverse distributes, and that's what they call factoring out by grouping, when you're grouping them in two different sets of two and factoring out something to get a common term or a common factor. So that's all we talked about today. Hopefully you can practice the ones that we didn't do. Oh, I missed one. See, that's me missing one, and then I'm going to go back and study that one because that's the one I didn't remember, which is solving radicals where we multiplied by the flip, right? We flipped the thing and we exponented it to that flip. So if you had m to the n right there, we would flip it, call it n to the m, and then we would exponent to that. We would raise it to that power. And then we had that special rule, just like we do with when we raise something to the third or raise it to the squared, that you got to think about your plus or your minus sign or not, based on whether it's odd or even. All right. Thanks for watching. Make sure you're asking questions. If you have questions, make sure you're looking over the material and trying it on your own, trying practice problems, make sure you're doing the homework, all of that good stuff. I'll see you in class, and thanks for tuning in and trying to learn a little bit.